Okay, welcome back everyone. In this video we're going to be looking at number 44 on page 726. So this is an example of total internal reflection. And so in this problem we have a beam of light which is to undergo total internal reflection through a 45-90-45 prism, which looks kind of like this. Let me clean that up a bit. Okay, close enough. And so we have 45, 45, and 90. And the first part of the question asks us to say whether the arrangement will depend on the index of refraction of the prism, so we'll call that N2, the index of refraction of the surrounding medium, we'll call that N1, or the indices of refraction of both. And so of course it turns out that based off of Snell's law, that the critical angle is the inverse sine of N1 over N2. Okay? And so what this means is that, of course, it will depend on both. And then for part B, we want to calculate the minimum index of refraction of the prism if the surrounding medium, so N1, is air. And then we're to repeat it if it's water. Okay, so basically what happens is we have a ray of light which enters, and if it enters perpendicular, there's no refraction which takes place. It just goes straight on through, and then when it hits the back surface, we want total internal reflection. So since this is a 45, 45, 90, it's going to reflect straight down. Okay? And so basically what we want to do is try to calculate, well, what kind of index of refraction do I need for N2? So let's say that N1 is equal to 1. Okay, now the critical angle is going to be this angle right here. And because of the geometry, theta critical is going to be 45 degrees. So this makes it pretty easy. Okay? So basically, what this means is that, well, we can take this equation and rewrite it and say that the sine of theta critical is equal to N1 over N2. So that means that the sine of 45 degrees is equal to 1 over N2. And this means that N2 is 1 over the sine of 45 degrees, which turns out to be 1.41. So this is if N1 is equal to 1, which corresponds to air. Now if N1 is equal to 4/3, which corresponds to water in the next part of the problem, it's the exact same calculation. We just have 1.33 over the sine of 45 degrees, and that turns into 1.88. So what this tells us is that the denser the surrounding medium, the denser the inner medium, or the refracting medium, the prism in this case. And that's because we want to maintain this 45, 45, 90 geometry. And one last fun tidbit before we go is that the index of refraction for diamond is nearly 2.4. So diamond is extremely dense. Think about the processes that make it. You got to smush carbon together at very high temperature and pressure. And because of that, light travels very slowly inside of diamond. Okay, well that's it for this time. And next time we will start talking about dealing with mirrors and lenses.